Hello, my name is Kelsey McCarter, and up first today we're going to talk about climate change. I know it's a buzzword in the media, and everyone here is already thinking about what they know. The problem is that there's a lot of misinformation floating around about climate change and its impacts, and everyone here has a different base knowledge, some of which may have been informed inaccurately. So to begin this town board meeting, let's dive into some climate change facts as well as their implications for our beloved city. Asheville, North Carolina is truly an amazing place to live, and we almost want to do what's best for it or we wouldn't be here. For those who do not know, we are situated in the French Broad River Valley at the juncture of the French Broad and Swannanoa rivers. Our elevation on average is around 2,200 feet above sea level. Asheville is part of the Southern Appalachian Mountains and the Blue Ridge Mountains, which is the second oldest mountain range on Earth. Even older than these mountains is the French Broad River running through them, the third oldest river on the planet. We are also a heavily forested city and have two national forests nearby, Pisgah and Nantahala. Asheville sits on an uneven plateau between the surrounding mountains which increase rapidly in elevation, with the highest peak in the Appalachian Mountains a mere 33 miles away. Despite being less than 46 square miles in size, Asheville's population is growing quickly, with an approximate increase of 11.3% in the last decade. Already, we are the main metropolitan city in western North Carolina with a population of 93,350 people. That being said, Asheville requires around 22.68 trillion British thermal units of energy annually to support its population, and this amount will only increase. Since Asheville has pledged to end greenhouse gas emissions by 2030, the growing population cannot continue to rely on the existing natural gas plant if we hope to meet this goal. I will be discussing climate and climate change a lot during this presentation, so let's make sure we are all on the same page with some of these terms. First, climate and weather are not the same. Weather is short term. You can look outside and see it. It changes within minutes and hours due to local atmospheric conditions like air pressure, water vapor concentration, temperature, and air movement. For instance, low air pressure systems can cause Asheville to have rainy days. That being said, weather is observed over hours and days. Climate, on the other hand, is observed over years. It is determined by an area's patterns of weather over time. You cannot look outside and see the climate, but you can evaluate patterns of rainfall, humidity, and temperature to see if an area has a tropical, dry, temperate, continental, or polar climate. In the figure to the left, you can see how rain can come and go, which affects the daily weather. However, regular patterns of rain over time can lead to a tropical climate. Asheville is considered to have a subtropical climate with mild, somewhat cold winters and a humid, relatively hot summer. Changes in weather happen every day, but changes in climate are more impactful because they mean that these patterns over time are shifting, and it is much harder to reverse such long-term changes. Many of the causes of climate change are natural and have occurred throughout Earth's history. However, global warming is solely due to human activity and is increasing the rate at which these changes are happening. This means that causes of climate change can be broken up into natural, or causes that happened before humans and are still happening, and anthropogenic, or causes which are specifically human-driven. One natural cause, which occurs over millions of years, would be the shifting of tectonic plates. This causes land masses to move, which changes land formations, how much moving water Earth has, and the planet's albedo, or reflectiveness. This is important because it forms mountain ranges which affect airflow around the globe, and land shifting into a different latitude can change climates. Also, if there is more moving water near the poles, more ice will melt, which decreases how much reflective surface that the ice provides against solar radiation. These plates form the mountains we live in, which contributes to our climate. Another natural cause, which occurs over hundreds of thousands of years, is the slow change in Earth's orbit and tilt and position of its axis. This is important because it changes the positioning of all land masses and bodies of water in relation to the sun. This indicates that Asheville's location has received different patterns of sunlight and heat in the past, which would determine the area's climate changes over time. These are some examples of natural causes. However, those are not ones we can control. Anthropogenic, or human-made causes, are under our control and involve us all working together. One of the major anthropogenic causes which affects climate change yearly is the burning of fossil fuels. In 2020, the USA relied on fossil fuels to provide 79% of its energy. Burning fossil fuels releases carbon dioxide among other greenhouse gases into the atmosphere, which will stay there for up to 1,000 years. If Asheville wants to be emission-free by 2030, we cannot rely on fossil fuels, which includes our natural gas plant. Our plant has 544 megawatt capacity, which means that it can emit over 237 metric tons of carbon dioxide. Natural gas plants also emit methane, which is 28 times more potent of a greenhouse gas than carbon dioxide is. Our next presentation will discuss replacing this plant with a renewable energy source. Other anthropogenic causes which affect annual climate change are deforestation and urbanization. Forests and vegetation are one of the largest carbon sinks on the planet, meaning they absorb and store around 7.6 billion metric tons of carbon out of the atmosphere. Removing vegetation and forest cover reduces its effectiveness at storing carbon, which leaves more in the atmosphere to warm the planet. Fortunately, Asheville's regulations on removing trees has kept its forests intact, so deforestation is less of a threat as long as we maintain the preservation of our trees. However, Asheville is rapidly urbanizing. Natural features and carbon sinks are being replaced by developments and businesses, which is increasing Asheville's overall temperature. These causes, or forcing factors, of climate change have led to an increase of the average yearly global temperature by 1.04 degrees Celsius since the late 1800s, and this is projected to increase to 1.5 degrees Celsius by 2050. This will have devastating impacts on humanity and the planet, which will affect many generations since climate is long-term. The top image on the right shows carbon dioxide levels since 400,000 years ago, and the line is indicating the ceiling of atmospheric carbon dioxide that was not passed until 1950. This is a clear indicator that anthropogenic activities have significantly increased carbon in the atmosphere. The bottom image lists some other causes, effects, and social impacts of climate change. Natural and anthropogenic forcing factors have impacted Asheville's past climate. For instance, from around 1300 to the 1800s, many volcanic eruptions around the world expelled copious amounts of volcanic gases and particles into the atmosphere, blocking the sun and causing temperatures to decline. This area of the country experienced devastating winters alongside severe droughts, which led to crops failing, an increase in fatalities, famine, and rivers freezing. The gases and particles eventually dissipated, and the Industrial Revolution began, leading to a rise in global temperatures, ending this little ice age. Asheville has become warmer and wetter since. In fact, since the late 1800s, our average annual temperature has increased by over 0.5 degrees Celsius. This is approximately half that of the global increase, which means that our tree cover must be doing a good job. Even still, Asheville experienced its hottest year on record in 2015 and is experiencing hotter years more frequently as global temperatures continue to rise. Hotter years will come with more heat stress being put on the city, more food and water stress being put on Ashevilleans, an increase in flooding and wildfires, an increase in our water's acidity due to a higher concentration of carbon dioxide, and further loss of biodiversity. The image on the left was taken after the flood of 1916. Floodwaters washed away the supports, indicating how devastating floods can be to this area. Our recent flooding only proves it. This graph, based on data from NASA, shows the annual average temperature from Asheville from 1887 to 2020. The line going through these yearly averages is the line of best fit. This line is positioned by a linear regression model that locates the average which is closest to the data points. This shows average change over time, and as you can see by Asheville's line of best fit, our average annual temperatures are steadily rising. Since 1887, we have experienced an increase of 0.5 degrees Celsius and have had more record highs. Without significant and immediate changes, we can expect our yearly temperatures to continue to rise. This will result in more wildfires, flooding, higher heat stress, power and water system failure, less food and water security, and a considerable amount of spending on repairs. Socioeconomically, we will also see an increase in loss of homes and businesses, especially by low-income communities, higher taxes, more healthcare problems and fatalities, and a drop in Asheville's overall economic output from the decline in individual output, and a widening of the economic gap we already want to close. We would spend less money and face fewer problems by taking preventative measures such as replacing our fossil fuel centralized power plant with a renewable power system. There are many implications for Asheville if we do not make sufficient changes here and worldwide. Higher temperatures mean drier soil and vegetation, and since we have such dense tree cover everywhere and are located near 2 national forests, we are at risk for wildfires. More wildfires could overwhelm our fire department and properties would be lost. Also, since we are positioned where 2 rivers meet, we are at risk for flooding, as has been evident with the recent storms. This past summer, Tropical Depression Fred caused downtown to flood, as you can see in the image to the left. Just this past week, heavy rains caused river levels to rise dangerously. If Asheville continues to experience flooding like this, it will be increasingly difficult to keep up with repairs, and many will lose their properties, especially low-income families. Depending on how Asheville chooses to take preventative measures, it could have extreme socioeconomic impacts. We must fix our infrastructure, which is largely outdated and in need of repairs, if not replacing. However, if these measures are forced to be funded by citizens, many low-income communities will not be able to afford them and could lose their homes and businesses. Our homeless population already is sizable and in need of more resources, so making it larger will require further resources and harm Asheville's overall economic output. The city needs to fund preventative measures to avoid making its citizens suffer these environmental and socioeconomic impacts of climate change, and we need to start now. It's one thing to demand change, but having a plan is always useful. This plan can come in the form of large and small-scale mitigation strategies. Mitigations are ways we can accommodate and adapt in order to prevent further climate change. One of our major strategies would be to decentralize Asheville's energy production, which will stop reliance on the existing natural gas power plant. It will replace it with a renewable energy source as well as provide smaller renewable energy sources to communities. This would reduce our current emissions and increase every area's power security because a malfunction in one community would not impact other areas. The figures on the right show the power transfer differences between a centralized traditional power grid and a decentralized renewable power grid. The centralized system is very linear, whereas the decentralized system has much more independence and security. This would also save our citizens money on their energy bills, as well as create new jobs for our area, which can help prevent some socioeconomic impacts by freeing up money within communities to afford preventative measures and repairs on buildings under stress from rising temperatures and increased flooding. Another large-scale mitigation strategy would be to prevent flooding by restoring vegetation and stability to our riverbanks to help reduce erosion. Also, reconnecting floodplains, digging diversion channels, and installing levees and flow walls will prevent floodwaters from reaching homes and businesses. Choosing to fund preventative measures for flooding could be 5 times as cost-efficient as funding repairs, which will reduce negative socioeconomic impacts. Higher temperatures mean more extreme weather events, so we should expect more flooding and prepare. Another large-scale mitigation would be to hire a wildfire prevention team. This would be a year-round position, not just volunteering during high-risk times. And in order to provide continuous and accurate education and resources to locals so that they may make their homes and businesses more fire-resistant. They would also keep our forests clear of fuel and debris, as well as preserve our waterways so that fires cannot spread easily. This extracted debris and tree parts can be sold, recycled, as well as being turned into a renewable source of biomass energy. This will boost Asheville's economy and energy independence. Higher temperatures increase the risk for wildfires, and since Asheville has so many trees and forests, we need to take preventative measures now to avoid property loss and loss of life. These were all important large-scale mitigations, but small-scale mitigations would also be beneficial. If more families bought local food, products, and services, it would reduce their individual carbon footprints, meaning how many emissions they are responsible for because of their lifestyle. This would reduce emissions by greatly reducing the number of miles that food, products, and services have to travel for their consumption. Local items often only have to travel about 100 to 400 miles, whereas commercial goods can travel up to 1,500 miles. This would decrease the number of commercial vehicles in Asheville, thus reducing emissions as well. This would also boost Asheville's economy because more of its citizens would have a higher economic output. More local money also means more available to fund preventative measures and repairs, which we will need more of as temperatures keep rising. Another small-scale mitigation strategy would be for families to improve their home's heat resilience by painting their walls and roofs white. This will increase its albedo, or reflectiveness of the sun's warmth, which will decrease energy bills. They can also install vegetation on their roofs to make them green, which absorbs heat, keeping it out of the house and lowering energy usage. They can also paint their local roads white, which will increase its albedo and keep the entire area cooler, thus reducing energy usage. These would all lessen the demand for energy and lower bills, which can free up money for further prevention and repairs. With temperatures continuing to rise, more areas in Asheville are beginning to feel the consequences. The image on the left is a map of Asheville's zones and shows which areas are more vulnerable to climate change impacts. We should focus on these areas first in order to provide climate change prevention equity to our city. Asheville's climate is changing, but there are measures we can take now to not only reduce the impacts we experience, but also to learn to thrive in this new world.